Right, I am back. So we're gonna go over some more problems on here. Now I do have to bring this to your attention. Whenever you're taking this test, you gotta be quick. Right now we've been going pretty slow because I've been trying to explain everything, but literally you have 55 minutes to do about 45 questions, which doesn't give you a lot of time to do most of them. It's a minute and some change just per question, which is not a lot. And that's why this type of tests are kind of hard, because they're really trying to keep you on your feet. And if you get stuck in one of the questions, then basically you already ruined your chances to do well on the test. So whenever you're doing this test, if you really don't know how to do it, skip to another one. Skip to another, come back later. The worst that you can do is stay in one question for the entire, or maybe 10 minutes, 30 minutes, and then you got one right, but then you didn't look at any of the other problems. Okay, just throwing that out there. And it's kind of hard because some people are brand new, I have to do this problem and then I cannot skip it. Well, you're just gonna have to get used to it, because this type of test is actually really, it's gonna trigger that a lot. So it does with me, because I'm the type of person who I want to finish this problem and then move next. But if you don't get it, just move on. Now, number 12 is gonna be talking about perpendicular lines. Now, I was gonna explain it a different way, but I realized, okay, that's kind of dumb the way I was explaining it. So perpendicular lines are lines that are gonna be basically making an X. It's gonna look like this. Okay, now how do you tell one line is perpendicular to the other? So what we're gonna do is that the line is gonna be your original line, so your OL, and then your perpendicular line PL. Now this is your original line, and I'm gonna kind of describe it. So your original line, let's say, is 2. That's the slope. We're talking about slope here. That's your slope. And so your perpendicular slope would be the opposite of that. So it'd be 2 over 1, and we have to make it negative. So it'd be the inverse of it, plus we have to change the sign of it. That would be the perpendicular of each other. Okay? So that's what we're going to have to do with this problem. So in order to do that, we need to figure out the slope of the original equation. So in other words, you have to solve the top one for y. So pretty easy. So it's just negative 3x plus 4y equals 5. Now we go ahead and move this one over. So it's going to be y equals positive 3x and plus 5. And then we divide both sides by 4. So in other words, my slope for my original function is 3 or 4. That's what we're looking for, okay? That's the original one. And what we're looking for would be the opposite, but now negative. Okay, now we need to see which one kind of would give us that. Now, I'm going to look at my numbers, and I know I need to have a 4 and a 3. So I'm going to go ahead and I'm going to just go ahead and change this one into y equals. And then we'll see if it's perpendicular, if it gives me the slope. Now, the reason why I picked that one in particular is because I know it has a 3 and it has a 4. That's the only reason why I picked it. Because I'm trying to place, I'm trying to be smart, trying to pick the least amount of questions or problems, or trying to do the least amount of work in order for me to finish the problem. So let's go ahead and solve for that one. So it's going to be 4x plus 3y equals 5. Again, we do negative, so it's going to be negative 4x, which is going to give us 3y is equal to negative 4x plus 5. We divide everything by 3. Now we can see that we have negative 4 over 3, which is exactly what we got here. So that's my perpendicular line. So I didn't have to graph anything. Everything is basically done by hand. And now we can move to the next one, 13. Now, this is the type of questions, it's a system of equations. Type it out. That's all I'm going to say. If you have system of equations, type it out and see what you get. So it's going to be negative 1 divided by 3 x plus y. Oh, I typed it all wrong. Okay, so move that one over here. Then we put x plus y. Now we have the first equation. Now let's type in the other equation. So it's going to be 6 equals 1/3. I keep saying the wrong numbers. Just follow what's on the screen. Don't follow what I'm saying sometimes. because I do mix my numbers a lot. All right, so this is what we have, and I'm pretty sure I typed it in correctly. I'm double checking. Yes, so we have everything correctly. What you're going to be looking for, you're going to be looking at the point in which they're intersecting. Okay, then you're going to be looking for y value. They're asking you, so now they're asking for the y value. My y value is 8, so my answer is 8. That's it. That's all you have to do. Pretty easy, pretty straightforward. You didn't have to struggle. Now, this type of problem, the ones that you have right here, I would honestly, I would come back and do it maybe later. Just read it. If you don't get it, move on, because paragraph problems like this tends to like get people lost. So I'm gonna go ahead and read it. So a community advocacy group recently polled 500 people who were selected at random from a small town and asked each person, "Are you in favor of the referendum to increase the property tax rate?" Of those surveys, 67% stated that they were opposed to the property referendum. Which of the following statements must be true based on the results of the poll? If another 500 people are selected at random from the town were polled, 67% of them would state they are opposed to the property tax. Is that true? Actually, you don't know. You don't know. That one's, we cannot actually infer that's true. Now, if 500 people selected at random from a different town were polled, 67% then would report the opposed. No, same thing. We don't know anything about any other town, so that wouldn't apply. Now, of all the people in the town, 67% are opposed. And look, it says all the people. No, because they only surveyed how many? 500. So they cannot imply that everybody in the town, or this is going to apply to everybody in the town. It's just not. So actually my answer for this one's none. And it's just kind of like knowing and reading kind of carefully on those type of questions. Okay, now we have this one. Inequalities. Okay, so which one satisfies the inequality? And now whenever it comes to inequality, we're going to have a shaded area, and the points have to be on the shaded area. Okay, but there's going to be 3 shaded areas in this problem, and you'll see what I mean. So let's go ahead and just type them out. So whenever you get system equations, type them out and see what you get. So it's going to be 4x. Oh, I don't have my keyboard, so I cannot actually type in the inequalities, but what a bummer. Oh no, I do. I have them right here. I'm such a dumb. Okay, so -1. So that one, and then y. Boom, there we go. You see the inequality? That's going to be the shaded area. We need a point to be in that shaded area, but because we have 2 equations, it's going to be a shaded area, double shaded area. So you'll see it. So it's going to be 2. It's going to be greater than x plus y. Oh, there we go. We're done. So you see we have this shaded area over here on the top, this shaded area over here on the bottom, and this shaded area over here, which is double shaded. So my point has to actually land, for this to be true, in both cases has to land over here on the darker green. So we're going to go ahead and look at the points. We're going to have to get kind of close on this one, because it's kind of far and we cannot see real quick. Okay, right here. That should be good. So we're going to go to -3. So it's going to go -3. So around here. And then it's going to go to -1, which is this is in this area. Yes. Yeah, it is. So that's my answer. I don't have to do anything else. I know this one lands right there on the double shaded area, and that is my answer. Okay, that's for the inequality on that one. All right, let's go to the next one. Now, this ones are actually pretty simple whenever you actually look at them. But at first, it might be a little confusing. Now, this one's going to apply to 3 problems. So they're going to show you this, and it even tells you right there. 16 through 18 is going to refer to the following information. So this is talking about just going and working out what type of exercise, how many calories you're going to be burning per exercise. So in this case, we're going to have all of these different exercises, and those are the calories that you burn. Now let's go ahead and go to problem number 1. It says 2 100-pound people have each been exercising for about an hour. Now one is speed walking and the other one's doing yoga. Which of the following will be the closest to the difference? So we're gonna have to go ahead and find the difference between both of them. So I'm gonna highlight. We're gonna subtract. Now, of their total exercise times, okay, in minutes. But it's not, I'm gonna keep reading. When they have each burn an additional 20 calories. So, okay. So both of them are working out for an hour, right? But after the hour, both of them are gonna go ahead and burn an extra 20 calories. Meaning that we're gonna have to figure out, okay, so how fast is speed walking gonna get to that 20 calories, and how fast is the yoga person gonna get to those 20 calories? So let's go ahead and look at the respective things. So the first one is gonna be speed walking is 5. So we're gonna get 20, and we're gonna go ahead and divide it by 5, which is gonna give me 4. Okay. So in 4 minutes, the person speed walking is going to be able to reach those 20 calories. Now let's go ahead and figure out the yoga person. So the yoga person is going to be burning a 1.5 calorie per minute. So we're going to go ahead and grab 20, and we're going to go ahead and divide it by 1.5. Now, if you cannot do it in your head, always type it out. There's no shame in that, okay? You're going to have usually a calculator with you most times. And my answer is just going to be 3.333 or whatever. Now here is where we have to do the difference, right? We already know how long they're going to take. The speed walking person is going to take 4 minutes. The other person doing yoga is going to get 30 minutes. So what is the difference between their times? So we're going to go ahead. We type in 13.33 minus 4. My answer is 9.3. That is my answer for this one. And that's it. That's all you have to do for that one. Right? Nothing more, nothing less. We're done. Okay, pretty awesome. So now let's go ahead, go to look at the next one. It says, according to the information in the table, what is the approximate number of calories that will be burned by a 100-pound person shooting basketballs for 30 minutes? So let's go ahead and go to the table. Shooting baskets is going to be 3 calories. Now they did 30 minutes, so that means it's going to be 3 times 30, which is going to equal 90 calories. So this person is going to be burning 90 calories after shooting baskets for 30 minutes, which is not bad, actually. That's pretty decent. Okay, so let's go to 18. Now, right here we have a scatter plot. Okay, so the scatter plot above gives the time spent exercising plotted against the calories burned. Okay, for 20, 100-pound people doing particular exercise, the burn rate of which, the burn rate of this exercise is closest to that of which of the following exercises. Okay, so this is a lot of information going here. Now, all these people are doing a specific exercise. Okay. Now, what we're going to do, we're going to have to look at the relationship between the time they're actually working out and how many calories that we're burning. Once we figure out that relationship, one of those is going to give us the burn rate. Okay? So this is how it's going to work. I'm going to go ahead and look at 10 right here. Now, I'm going to see at 10, how high or how close are they to the calories burned. So in 10 minutes, these people are burning about 20 calories, okay? So what is the burn rate? So what we're going to do, we're going to go ahead and do 20 divided by 10, which is going to equal 2. So people are burning about 2 calories per minute. So what exercise is burning 2 calories per minute? Well, not that one. There we go. Light aerobics. And that is my answer. That's how we figure out that one. Okay, so it wasn't too difficult. We just had to figure out the burn rate. All right, let's go ahead. Now let's go to 19, and that's where we're going to stop. All right. So right here, or actually we might be able to keep going. We'll see. So the figure on the left above shows an electric fan with a spot of paint on one of the blades. The electric fan is sitting on the flat desk and is switched on a constant low setting causing the blades to rotate clockwise. All right. The graph of y equals ft on the right could represent which of the following as a function of time from the electric fan was turned on. Okay, so we're trying to figure out what kind of relationship is this. Okay, what would that give us? Now, obviously, it's going to have to be something about distance, right? Because it's going up and down. And the amount of time that it's going is just keeps going up and down. So let's read them. So the distance traveled by the spot paint, well, that wouldn't necessarily make sense. Well, could? No, I don't think so. Because how much distance is that rotating? So I'm guessing that's not going to be it. And then the distance of the spot of paint from the center of the electric fan. No, that wouldn't be it, because this one is not going to change the distance from this. So that wouldn't make sense. That wouldn't give us the little loop, because that would be very constant, because it's not going to change the distance between there and there. So let's go ahead and read the next one. The distance of the spot paint from the desk. Okay. So that could actually work, right? Because as time goes by, it starts getting higher, right? It starts getting higher. So let's say it moves over here. But then time keeps going, and then it's going to go back down here. And then it goes, okay, so that might be right. So let's put a little check mark. The speed at which the blades of the fan are moving. Okay, actually, no. That has nothing to do with it. All right, so I'm going to go ahead, and my answer is going to be C. Because that's the one that makes more sense to me. All right, because it's going to be the distance between the desks, and you can actually see it go up and down because it's getting closer to the desk and